relative reactivities of carboxylic acid derivative towards nucleophilic acyl substitution reaction. Okay, what's mean by this subtopic? So reactivity, okay, reactivity of acid derivative towards nucleophilic attacks depends on their structure and also depends of nature of the attacking nucleophile. Okay, there are two reactivity on this nucleophilic attack. First, we look on the structure, and number two, nature of the attacking nucleophile, structure and attack by nucleophile. Okay, first, unhindered carbonyl group. What's mean by unhindered carbonyl group? Okay, this nucleophile react better with unhindered carbonyl group. Unhindered means that less bulky or it's not crowded area at a carbonyl group. So unhindered carbonyl group have less steric effect. Okay, unhindered carbonyl group is less steric effect. It means it's less bulky. The structure on the carbonyl group is less bulky, so makes carbonyl group more electrophilic. Okay. Okay, this one carbonyl group, okay, the surrounding is less steric effect or less R group, so it's become more electrophilic. If the carbonyl group is more electrophilic, so it's more reactive to addition happen. Okay, so this one example carbonyl less reactive and this one is more reactive. Okay. If you can see here the difference among this carboxylic acid, among this C double bond O, look at the surrounding of C double bond O. So here there are 3 R group, here is 2, 1 and no R group. So if the carbonyl group attached with less of alkyl group, so it's become more electrophilic. If more electrophilic, so the carbonyl group is more reactive to addition is occur. Okay, so next example, propanoyl chloride is more reactive with a nucleophile with the that compared to the 2,2-dimethylpropanoyl chloride. Okay, this structure compare with this structure. Okay, look at here C double bond O. So how many alkyl group attached on this C double bond O? So there are only 1 alkyl group. Compare this one, there are 1, 2, 3 alkyl group. So this one structure is more bulky compared to this one is less bulky. Less bulky we call as unhindered. Okay, but for this one bulky we call as hindered. Okay, tetrahedral carbon resulting from addition to propanoyl chloride less sterically hindered compared to this one. It's more bulky because of the shape of the carbon is tetrahedral. Okay, if tetrahedral is less bulky, this one is bulky. So if bulky is very difficult for nucleophile to attack. For this one C double bond O compared to this one is very easier nucleophilic to attack C double bond O because of less hindered, okay, or less bulky compared to this one. Okay, number 2 is about basicity of the leaving group. Okay, because there are two effect or there are two points for the reactivity. First on structure, okay, this one for structure, bulky or less bulky, and next is basicity of the leaving group. We know that the leaving group, why there are many types of functional group attached on acyl group. So strong base are not good leaving group. Strong base not good leaving group. Reactivity or derivative will decrease as the leaving group become more basic. Okay, a better leaving group, so react better with nucleophile. Okay, so the point here I want to tell about the basicity of leaving group. If the strong base, okay, so are not leaving group, but for the other of the leaving group, if good leaving group is better to nucleophile attack. Okay, such as Cl minus, we know this is a leaving group from halogen, so weakest base, and but is good for leaving group. Okay, this is a weakest base. Okay, because basicity depends on basicity of leaving group. This one is leaving group. Okay, halide is weakest base. So if weaker base is okay because will give a good leaving group. Okay, acyl chloride is the most reactive compared to other carboxylic acid derivative. Okay, there are many carboxylic derivative, but for acyl chloride or acid chloride is the most reactive. Okay, compared to the other because of chlorine is a weak base and produce a good leaving group. So here is table for reactivity. As you can see here, this is a derivative of carboxylic acid, and this one is leaving group attached on the derivative. Okay, so here halogen followed by this one is amine, so it's more basic. Okay, amine is more basic, so it's less reactive compared to halide. Is more reactive because of halide less basic. Okay, number 3, so effect of substituent. Okay, reactivity of the carboxylic acid derivative influenced by the substituent. Okay, now we focus or we discuss about the substituent effect. Okay, substituent is electron donating, so carbonyl becomes less electrophilic. It means less reactive. Okay, substituent. If the substituent is electron donating, so carbonyl become less electrophilic. If carbonyl C double bond O less electrophilic, then it's less reactive. Okay, because in nucleophilic substitution, we want make a carbonyl more electrophilic so that nucleophile can attack on C double bond O. Okay, if the substituent is electron donating, so what happened? The carbonyl is become less electrophilic. If less electrophilic, so the reaction is very difficult to nucleophile attack on C double bond O. If the substituent from the electron withdrawing, so the carbonyl become more electrophilic. Okay, once carbonyl become more electrophilic, so it's more reactive. It means easier for nucleophile attack on C double bond O. It's better if the carbonyl C double bond O, the substituent is electron withdrawing. So here is summarized for interconvention of derivative. Okay, look at here. So less reactive. Okay, less reactive for carboxylic, but more reactive for acid chloride. Okay, more reactive derivative can be converted to less reactive derivative. Okay, this one is more reactive and this one is less reactive. Less reactive means that this electrophilic is donating, so that's why the nucleophile is very difficult to attack this one. Compared to this one, nucleophile easy to attack C double bond O because of the substituent is electron withdrawing. Here some of exercise. Okay, so the next subtopic is reactions of carboxylic acid derivative. This is just a general reaction, so after this we focus more detail about every of carboxylic derivative reactions. So this one, if you can see acid derivative using a different of reagent, so different of reaction and followed their product. It depends on the reaction and reagent. Okay, so this one is summarized in table. You can see here from the previous slide. Okay, come out with in table. Okay, and then actually for carboxylic derivative, So the general reaction are hydrolysis, alcoholysis, aminolysis, reduction, and Grignard reaction. Okay. So here is nucleophilic acyl substitution reaction of carboxylic acid. Acyl, why acyl? Because most of the carboxylic acid derivative, okay, must have acyl. So OH into a beta leaving group. Okay, specific region. Okay, here is carboxylic acid. Okay, and this one are, okay, this one are the derivative of carboxylic acid.